So how are we going to use this thing called specific heat? All right, it works like this. Let's remember we have our boiling pot, and so let's take a look at what's going on with our pot here. And we have, let's attach a picture. Can I do this? Insert a picture. I think I took a picture of our pot. Let's take a look. And there we go. Lots of pictures of my cat. Okay, so here is our pot, and we know that this thing is made up of two different parts. Let's get some ink going here. Okay, so this part of our pot, this handle, is aluminum, but the rest of our pot is iron. And these are two very different substances with two very different, what we're going to call specific heats. So here is a chart that we're going to use that shows us what are the specific heats of a bunch of different substances. So here's our aluminum right here, and it has a specific heat with a value of 0.897. We'll get into what the units are in a little bit. And here's iron. Notice that aluminum is way higher. What is this thing called specific heat? So here's how this works. We're going to say that specific heat, it is the amount of energy we'll say required to raise the we'll say to raise the temperature of 1 gram by 1 degree Celsius. So we're going to use for energy, we're going to use a new unit. We're going to say energy, we're going to measure in joules. We'll abbreviate this J. It's a unit of energy that in the United States we use calories. This is the metric unit. Okay, so in America we say how many calories are in this or in that, and in Europe or in the rest of the world that uses the metric system, they will say how many joules of energy are in this or that. So we have a really simple equation. We're going to say this: specific heat. We're going to abbreviate this specific heat, and the equation is going to look like this. Okay, this guy, Cp, this is going to be specific heat. This guy, Q, this is going to be energy in joules. This guy, M, is going to be our mass in grams. And this guy, delta T, is going to be our change in temperature. And it doesn't matter what unit that we use. We'll use degrees Celsius, but we can also use kelvins because they're the exact same unit. So, and notice up here it says this is in joules per gram. Kelvin, well, you can replace that with degrees Celsius and it works exactly the same way. So here's a question you can expect me to ask. And first off, before we do that, what's going on here is that aluminum has a specific heat of 0.897 joules per gram degree Celsius. That means that it requires twice as much energy as iron to raise its temperature. And so if our pot is on our gas stove here, and the water is boiling because the iron is hot enough to make the water boil. That is not enough energy to make the aluminum as hot. So you can grab this part, no problem. If you grab the iron, however, that same amount of energy coming off of our gas stove will make the iron way hotter than the aluminum, because iron only requires half as much energy, 0.449 joules per gram degrees Celsius. So let's try one of these, and then I'll show you how we're going to use this equation. Okay? So I like, well, since this equation looks like this, Cp equals Q over M times delta T. I like writing it a little differently. I like writing it like this: Q equals Cp times M times delta T. This is a little easier to flip around, because that way you can use it to find mass. Mass is going to be equal to Q over Cp times delta T, or you could even use it to find delta T. You could say that delta T, the change in temperature, is equal to Q over Cp times M. So I'll give you a couple of examples, and then I'll stop and let you guys try this yourselves. Okay? And so we'll say, here's a question that you could expect me to ask. How much heat, how much energy in joules is required to raise the temperature of 500 grams of iron from 25 degrees Celsius, which is room temperature, to 100 degrees Celsius, which is the temperature at which water boils. Okay, so a couple of things that we want to know. We are trying to find energy. We're trying to find Q. Cp is something that we're usually given. It's often in a table. And so here is our table that tells us that iron has a specific heat of 0.449 joules per gram degrees Celsius. So we'll put that right here. So we'll say 0.449 joules per gram degrees Celsius. We'll say M, our mass. It tells us right here, our mass, 500 grams. And we want to be pretty careful here, because when it says delta T, let's remember that that delta T, that delta stands for change in temperature. Well, we went from 25 to 100, and that means that our delta T is 75 degrees Celsius. So let's plug this in. We want the version that's solving for Q. Q equals Cp times M times delta T. We know the specific heat, 0.449 joules per gram degrees Celsius. Joules per gram degrees Celsius. We know the mass, 500 grams, and we know the delta T. We just found that, 75 degrees Celsius. Now, when you do this, if you can pay attention to the units, it helps a lot, because look what happens. Degrees Celsius cancel, grams cancel, and it leaves our answer in joules, which is what we want. We're trying to solve for energy. So I'm going to bust out my calculator, which I have right here. And let's move this so I can see what I'm doing. And so we have 0.449 joules per gram degrees Celsius times 500 grams times 75 degrees Celsius. Ladies and gentlemen, here is our answer in joules, 16,837.5 joules. That's our answer. Okay? So I'd like you all to try this. Some of these questions may ask you to use different versions of this equation. I'll put them all on there so you all have it. Okay? And in fact, I will even do one of them for you so you can see what I'm talking about. Okay, so this one is going to be problem number 3 from the homework. Okay? It says, what mass of liquid water at room temperature can be raised to its boiling point with the addition of 24 kilojoules of energy? Now, 2 things here. You're going to say, Mr. O, we don't know what the boiling point of water is. Yes, you do. Don't give me that. 100 degrees Celsius. And this is in kilojoules. Now, there's a reason why I tried to teach you guys the metric system at the beginning of the year, so that you could go from kilo this or that to back and forth without a whole lot of hassle. And you know that 24 kilojoules is the same as 24,000 joules. You should know that because you should know that 1 kilojoule, 1 kilo anything is 1,000 of that thing. Okay? So it's asking for mass. If I know that the equation for specific heat looks like this, Q is equal to Cp times M times delta T, I'm going to flip this around to find mass. Now, if you don't know how to do this, that's cool, but I put it right up here. Okay? So that's where it's at, even if you're not really cool with deriving equations. So mass is going to be equal to Q over Cp times delta T. All right. I like to identify my variables. We are trying to find mass. Specific heat is something that we're given. This is liquid water right here, liquid water. And so here in our table tells us right off the bat, oh, look at that. Water's got a couple of different versions. We want the liquid one, 4.18 joules per gram degrees Celsius. So there's our specific heat, 4.18 joules per gram degrees Celsius. We know our delta T because we are going from 25 degrees Celsius to the boiling point, which is 100. Oh, look at that, just like the previous example. And the Q, which is our energy, 24 kilojoules, otherwise known as 24,000 joules. So I'm going to plug them right into this equation. We've got 24,000 joules, a specific heat of 4.18 joules per gram degrees Celsius, and a delta T of 75 degrees Celsius. Now, if you are paying at all attention to the units, degrees Celsius cancels, joules cancels, leaves us in grams. So I'm going to bust out my calculator and I'm going to get all fancy because I'm going to do this all in one shot. So I'm going to say 24,000 divided by everything on the bottom. I'm going to do it all in one shot by putting everything that's on the bottom in parentheses. Otherwise, your calculator is going to get confused. So 4.18 joules per gram degrees Celsius times 75 degrees Celsius. Close those parentheses. And here is our answer. What is our mass? Call that 76.6 grams of liquid water. And ladies and gentlemen, that's all you do.